Okay, so here is question 19 from chapter 8, individual assignment. And unfortunately with this one, we can't use the confidence .norm or confidence.t function, which would be really nice. Instead, we're going to have to go through this whole process of figuring out the confidence level. So all we can really do, all I can do, and I'm not sure, is I start with what I know, okay? So I know my alpha, because that's based on the confidence interval. 1 minus the confidence level. 1 minus the confidence level is my alpha. So in this case, it's 0.1. I know my x bar, which is my sample mean, which is given to me right. It says the average radon level was found to be 1.4. That's my sample mean. I know my population standard deviation, because it tells me that from past studies, the population standard deviation is 0.5. I know my little n, which is my sample size. This says a random sample of 30 homes was selected. I know my big N, which is my population size, which is 106. And that's what I know at this point. So I know that if I can't, the reason I can't just use confidence.norm when I normally would be able to is because I have a I have a large sample size relative to the population size. So that's going to require me to use the finite population correction factor. And in order to do that, I have to use it on my standard error of the mean. So I'm going to have to calculate my standard error of the mean. And the standard error of the mean is just the square root of the population standard deviation. I'm sorry, this population standard deviation divided by the square root of n, of little n, okay, of the sample size. So that's my standard error of the mean. And then I'm going to have to correct that with a finite population correction factor. And I have to do that anytime the sample size is large relative to more than about 5% of the population size. So in this case, I've got a sample size that's almost 30% of the population size. So to calculate that, I'm going to take the square root of big N, which is the population size, minus little n, divided by big N minus 1. So there's my finite population correction factor. So I'm going to call this my corrected standard error of the mean, which is just going to be my standard error of the mean times the finite population correction factor. I call it correct. It's corrected. All right. So once I have my corrected standard error of the mean, I can calculate my confidence interval. The confidence interval is just the z-score of alpha divided by 2 times the corrected standard error of the mean. So I'm going to have to find the z-score of alpha divided by 2. Okay, so in order to do this, I want to take the absolute value because I don't want negatives in there. The absolute value of norm.s.inv, so the inverse of the normal distribution. And for the probability, I'm going to use my alpha divided by 2. So that's going to give me the z-score of my alpha divided by 2, or the absolute value of my z-score, of the z-score of the alpha divided by 2. So now I can calculate my confidence interval, which is just going to be my corrected standard error of the mean times the z-score of my alpha divided by 2. Then once I know my confidence interval, I can do my lower or the lower range of my confidence interval, which is just going to be my mean, or x bar, minus the confidence interval. My upper is going to be my x bar plus my confidence interval. This wants our answer into 2 decimal places. I always like to do this just so I don't make a mistake. So we're going to say that we are 90% confident that the level is between 1.27 and 1.53 picocuries per liter. Then it asks us to sort of analyze this. It says, does it appear the average radon level is below the recommendation? So this says the recommended radon level is less than 4 picocuries per liter. And we're saying that we're 90% confident it's between 1.27 and 1.53. So we would say, yes, we are, it does appear that the average radon level is below because all of the values in the confidence interval are less than that recommended level of 4. And there you go. Hopefully that was valuable to you, and good luck. Well, this is the last question, so hopefully that finishes up the assignment for you.